Everyone, welcome back. So yes, good afternoon to all of you. So today we are going to talk about, so many good afternoons. Okay, Pramod, Ashutosh, Swati, Ayushi, Nikita, Sunil, Prasanta, Soumyarajan, Akshata. Yes, very good afternoon to all of you. Okay, so let us now dive into the chapter on integration. Okay, last time we have done differentiation, and I'm so happy to see that so many of you have put the comment that now you're no longer afraid of differentiation. So let us do the same thing with integration also, and let us make sure that we will be attempting those questions. Okay. Yes, Kavya, Dimple, Tamanna, Anushka, Ritu, Aryan, Suchiang, Yashraj. Okay. Okay. So, see, what we did last time was that when we wanted to talk about rate of change, we use differentiation so that when my independent variable changed by a small amount, how much did my dependent variable change? Okay. So, to express the rate of change of any function, okay, to express the rate of change in any function, we were introduced the concept of derivative. Okay, just let me make it a little thicker so that you can see it properly. So it involves a very small change in the dependent variable with reference to a very small change in the independent variable. So what we do is we try to change the independent variable by a small amount, and then we try to see what is the change in the dependent variable. Thus, differentiation is the process of finding the derivative of a continuous function. Okay. Now, integration, on the other hand, is the reverse process of differentiation. Okay. So, I have a function. Okay. I have a function. What do? I differentiate. I find d by dx of fx, which is also written as f dash x. And then when I integrate this, when I integrate f dash x, I should get this function. Yes, there will be a constant, etc. But the concept, the theory behind is that if I have differentiated a function and if I integrate the differentiation, I should get back the original function. Okay. Now let us recall all our differentiation formulas. This is important because in case you don't remember a integration formula, what you can do is you can simply integrate the differentiation formula that you have, and then you can find the correct answer. Okay. Now we know that d by dx of xn is n x raised to n minus 1. So last time we did that if I have d by dx of x cube, this is equal to n is how much? 3. So this is equal to 3 x raised to 3 minus 1. How much is 3 minus 1? It is 2. So this is the derivative of x raised to n. Then we talked about d by dx of the exponential function e raised to x. We said that when I differentiate the exponential function, I'll get the exponential function back. Okay. Then d by dx of a raised to x is equal to a raised to x log e. So that if I have to find the d by dx of 3 raised to x, this is equal to 3 raised to x log 3 to the base e. Okay. And we also talked that 3 raised to x is not equal to x raised to 3. Okay. So this is, you have to be very careful that 3 raised to x. What do you mean by 3 raised to x? Suppose let x be equal to 4. Then 3 raised to x will be equal to 3 raised to 4, which is equal to 3 into 3 into 3 into 3. Okay. This is the meaning of 3 raised to x. Okay. This is just an example where I've taken x is equal to 4. Okay. But when I'm talking about x raised to 3, what is it? This means x into x into x. Okay. So this is the small bit that sometimes children get confused, and then you even though you know the correct formula, you're not able to apply it. Okay. So d by dx of a raised to x is a raised to x log a. Then d by dx of a constant is always equal to 0. Okay. This I have explained with the graph also. I've shown you the line and then told you that when I differentiate this constant, it is equal to 0. Then d by dx of e a raised to x. Here I have e raised to x. Here I have e raised to ax, which is equal to a e raised to ax. Okay. And d by dx of log x is equal to 1 upon x. Okay. So these are the basic differentiation formulae that I need to know, so that once I'm doing my differentiation integration also, I can use these concepts. Now, what are the formulas? So this is the first formula that we are talking about, which is the most used one. Okay, 1, 2. Just let me check everything. Yes, Yashraj, Ritu, Ananya, Bharat, Sherry, Kevin, Arushi, Shruti, Purva, Liza, Shruti. Yes, Shruti. Yes. Okay. So this we are talking about now, the integration formula. Integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Here this condition is very important, n not equal to minus 1. Which means that if I have integral, x raised to minus 1 dx, then I cannot apply this formula. Integral of x raised to minus 1 dx is equal to integral of 1 upon x dx. Remember in indices we have written a raised to minus 1 is equal to 1 upon a. So x raised to minus 1 dx is integral of 1 upon x dx, which is equal to log x plus c. Okay, so this is a special case that you have to remember. For all other cases, this formula will hold. Only for n is equal to minus 1, you have, for n is equal to minus 1, it becomes x raised to minus 1 dx, which is equal to integral of 1 upon x dx, which is equal to log x plus c. Okay. Now, this also brings us to something very important, is that suppose I don't have anything, I just have simply integral dx. What this means is, that this is equal to integral 1 dx, right? If there is nothing written here, that means it's 1. Now this 1, I can write it as integral of x raised to 0. Indices a raised to 0 is equal to 1. So x raised to 0 dx. Okay. So when I have this, I can use this formula. What is my n? N is 0. What is my formula? Integral x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. So integral x raised to 0 dx will be equal to x raised to 0 plus 1 upon 0 plus 1 plus c, where c is a constant. So this is equal to x raised to 0 plus 1 is 1. So this is x raised to 1. What is there in the denominator? 1 plus c. This is equal to x plus c. Okay. So this is also a very important formula. I should have written 2 here. Okay. So integral x raised to n dx is x raised to n plus 1 upon n plus 1. Then integral dx is equal to x. And then integral of e raised to x dx is equal to e raised to x plus c. Okay. So here, and you have to remember this also, integral of x raised to minus 1 dx is equal to log x plus c. Is that clear? Are these 4 formula clear? Yes, Vadekar, good afternoon. Okay. Dimple, I'll take that. we'll be doing it together in the differentiation and integration. Okay. Yes. Other than that, has everybody understood these four formula? Integral of x raised to n is equal to x raised to n plus 1 upon n plus 1 plus c. Integral of dx is equal to x plus c. Integral of e raised to x dx is e raised to x plus c. And integral of 1 upon x dx is equal to log x plus c. Okay. Now, what will happen when there are certain the same formula? Yes, Akshata, Vadika, Shruti, and Kevin. Yes, understood? Excellent. Now we know that integral of e raised to x dx, we know that integral of e raised to x dx is equal to e raised to x, right? What will happen when I have integral e raised to ax? Means, for example, I have integral of e raised to 3x dx. What will happen then? Then it is e raised to ax upon a plus c. Okay, then it is equal to e raised to ax upon a plus c. Like, see, here we have x raised to n upon n plus 1. Here also we have e raised to ax upon a plus c. Okay. Then similarly, integral dx upon x is equal to log x plus c. We have already done that. Then integral a raised to x dx is equal to a raised to x upon log a plus c. So, integral of a raised to x dx is equal to a raised to x upon log a to the base e plus c. Okay, to the base e is important. So, we are using this formula. We will do some sums and then we will consider some more formula and then we'll do more sums. Okay. So let us take this as I think on page 8.2, 8.25. Okay. Let us try to solve these sums. Okay. When you are wanting to study integration, just make sure that you've studied your indices again, just refresh those indices. Yes, Pramod, very good. Now let us take the first sum. It is on page 8.25. I am taking it very slowly, okay, so that all of you understand it very well. So I have integral square root of x dx. Now square root of x can be written, any square root rather, is written as something raised to half. Suppose I have fourth root of something. This will be equal to this raised to 1 by 4. Okay. Since this is only square root, this is anything raised to 1 by 2. Why this is important is because in this formula, I need the value of n. Okay, this n. So I must know this. So what we are doing is integral of square root of x dx is equal to integral of x raised to 1/2 dx. Okay. Now n is equal to 1/2. What is my formula? My formula says integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Okay. So this will become integral x raised to 1/2 dx is equal to x raised to 1/2 plus 1, and in the denominator I will write 1/2 plus 1 plus c. Okay. So how much do I get? 1/2 plus 1 is x raised to 3 by 2. X raised to 3 by 2 upon 1/2 plus 1 is again 3 by 2 plus c. Okay. Now in the denominator what do I do? Because it is 3 by 2, I will flip. anytime you have a fraction in the denominator, you flip. So the denominator of the fraction will come in the numerator. That is 2 by 3 x raised to 3 by 2 plus c. Okay. You may even have it in this form. This is same as this, which is equal to 2 by 3. Instead of x raised to 3 by 2, instead of x raised to 3 by 2, I can write it as x into x raised to half. Okay. Instead of x raised to 3 by 2. So this is equal to x. Instead of x raised to half, what can I write? Anything raised to half, I can write it as square root. So this is x square root of x plus c. Okay. These are same things. Okay. Answer is the same, but the presentation is different. So you can here see that integral of square root of x dx is equal to 2 by 3 x root x plus c. Okay. Yes, Kevin. Yes. Okay. Now let us go to the other one. Okay. Now I have 1 upon square root of x. Now in the earlier sum, we had square root of x, integral of square root of x. Now here I have integral of 1 upon square root of x. So I know that square root can be written as raised to half. And I also know that 1 upon a can be written as a raised to minus 1. These are the two properties we will be using. Okay, these are the two properties of indices we will be using. So that this can be written as integral of 1 upon square root of x dx is written as integral of 1 upon, instead of square root, what am I going to write? X raised to half dx. Now I will use 1 upon a is equal to a raised to minus 1. So this will become integral of x raised to minus 1 by 2. A raised to plus 1 becomes a raised to minus 1. So this becomes x raised to minus 1 by 2 dx. Okay, now I apply the formula. My n here is n is equal to how much? Minus half. Is it minus 1? No. If had it been minus 1, I should have used the other formula. Integral of 1 upon x is equal to log x dx. Okay. But here n is equal to minus half. And n plus 1 will be equal to minus half plus 1, which is equal to half. Okay. So this will become, this is equal to x raised to minus half plus 1 upon minus half plus 1 plus c, which is equal to x raised to half upon half plus c. So half, this 2 is in the denominator of the denominator. This is equal to 2 x raised to half plus c. Now answer will usually be written in this symbol. So this is equal to 2 square root of x plus c. Is that clear? Okay. So the two indices properties we are using. Yes. Yes. Everybody is understood? Great, great. Very nice. Asif, I did not get the question. Can you just tell me what more you want? Kushal, you want me to repeat? Okay, I will repeat. Yes. How to calculate half into square? See, okay, this is square root, not square. Okay, this is square root. Let me take another color and explain. Okay, I'll just repeat the sum because this is very important. You need to understand these sums. If the simple ones you understand, you can, these are the building blocks for the other sums. Okay, so I have integral 1 upon square root of x dx. Okay, now this 1 upon square root of x, I use 1 upon a is equal to a raised to minus 1. So what will this become? This is equal to integral of, okay, first let me use square root is equal to something raised to half. So this square root, I will write as something raised to half. So this is 1 upon x raised to half, right? 1 upon x raised to half dx. Now, 1 upon x raised to half. So 1 upon a is a raised to minus 1. So this will become integral of x raised to minus half dx. Okay. So just plus 1 becomes minus 1. So plus half will become minus half. And now I will use this formula. Okay. And I get n is equal to how much? N is equal to half. So x raised to minus half plus 1 upon minus half plus 1 plus c, which is equal to x raised to minus half plus 1. Minus half plus 1 is x raised to half. And here also minus half plus 1 becomes half plus c. This half in the denominator will flip. This becomes 2 x raised to half plus c. Now x raised to half will be written as here. Anything raised to half can be written as square root. So this is equal to 2 square root of x plus c. Yes, Suchiang, clear? Maima, Dimple? Yes, Dimple, if the n value is minus 2, minus 3, then also you will use this formula. Okay, only for n is equal to minus 1, there is a special case. Yes, Aisha, Ritu, Aryan, Purva, Kevin. Okay, Tanmeet. Yes, Suchiang, your indices have to be strong. Shruti, yes. Swati, clear now? Yes. Okay. Mahima, dx means what? Dx means I'm trying to increase by small amount. That small amount is dx. Okay. When I'm talking of small, I will write dx or delta x, you know. That is why that x, this is there. Okay. And there are lot many books on indices and integration if you want to go into details. But for the exam purposes, we are using whatever is the best method in which we can solve quickly. Now let us see. I have e raised to minus 3x dx. Had my integration been integral of e raised to x dx, the answer would have been e raised to x plus c. E raised to x plus c. Now it is e raised to ax, e raised to minus 3. So here a is equal to minus 3. Okay. Not only 3, it is equal to minus 3. So this you have to be careful. Now integral e raised to minus 3x dx is equal to e raised to ax. So e raised to minus 3x upon a. Upon a is, what is a? A is minus 3. Upon minus 3 plus c, which is equal to minus 1 by 3 e raised to minus 3x plus c. Okay. So for exponential, it becomes a bit easier. Okay. Let us go to 3 raised to x dx. Okay. So now this is the formula of a raised to x and not x raised to n. Okay. So a raised to x is a raised to x is a raised to x upon log a plus c. Okay. What is my a here? A is 3. So integral of 3 raised to x dx using this formula is a raised to x, that is 3 raised to x upon log a to the base e. So log 3 to the base e plus c. Okay. Yes, Kevin. Yes, you've already done that. Yeah, very good. Now see, this sum, you can also use the method of by parts, but when you have simple algebraic functions, it is best that you add or subtract their powers and make it into a smaller number. Okay, so pure algebraic, simplify and solve. Now, what am I going to use? I'm going to use that square root can be written as half. Okay, and I'm going to write a raised to m into a raised to n is equal to a raised to m plus n from the formula of indices. Okay, so my x into square root of x. Now, right now I'm not considering the integration. I'm just considering the algebraic function. X square root of x can be written as x raised to 1. Simply writing x is as good as x raised to 1 into square root of x can be written as x raised to half. Now 1 plus half, a raised to m into a raised to 1 is a raised to m plus 1. So this is equal to x raised to half plus, 1 plus half. I can write it that way also, but I don't want to confuse. 1 plus half. This 1 and this half, which is equal to x raised to 3 by 2. Okay, so x square root of x can be written as x raised to 3 by 2. So integral of x square root of x dx is equal to integral of x raised to 3 by 2 dx. Now what is n? Okay, now what is the value of n? Because I am going to use this formula. So here I have n is equal to 3 by 2. Okay, n is equal to 3 by 2, which I substitute in this formula, and I get this is equal to x raised to 3 by 2 plus 1 upon 3 by 2 plus 1. Okay, which is equal to LCM of 3 by 2 plus 1. So this is 1 upon 1. LCM will be 2. 3 plus 2, which is equal to 5. So x raised to 5 by 2 upon 5 by 2 plus c. So here there is plus c. Okay, so this will be the answer. And if you want to further simplify, the denominator of the denominator will become 2 by 5 x raised to 5 by 2 plus c. Okay, yes. These are the small things. Whatever small things I've written in colored, red and yellow and orange, that you have to be careful about. Okay. Other than that, you know the formula. Yes, clear? Excellent. Yes, Ritu, you've already done this? Yes, very good. Very nice. You solved it so quickly. Now, I have this formula for question. Now, what is the formula I'm going to use? A plus B whole square is equal to A square plus 2AB plus B square. Okay. A square plus 2AB plus B square. Okay. Now, this is equal to, what is my A here? A is equal to x. And what is my b? B is equal to 1 upon x. So simply x plus 1 upon x whole square, I will write it as a square plus 2 into a into b plus 1 upon b, 1 upon x whole square plus Okay, this is just the expansion. Okay, so expanding the given function. Okay, I've got this much. This is equal to x square. Now this 2, this x and this x will get cancelled. Okay, then I will have how much? X square plus 2 plus 1 upon x whole square will be 1 upon x square. This will become x raised to minus 2 dx. Okay, the minus sign is in the power function. So this will not cancel with this. This is the answer. Now putting it back, putting it in given equation, I will have integral of x plus 1 upon x whole square dx is equal to integral of x square plus 2 plus x raised to minus 2 dx. When I solve this, what will this become? X square will become x cube upon 3. 2 will become 2x. Okay. And x raised to minus 1. So, x raised to minus 2 plus 1 upon minus 2 plus 1. Which is equal to how much? X raised to minus 1. Minus 2 plus 1. Minus 2 plus 1 will become minus 1. So this is equal to plus 2x minus of x raised to minus 1 plus c. Okay, what will this become? X cube upon 3 plus 2x and x raised to minus 1. Okay, is equal to minus plus 1 upon x plus c. Okay, minus, sorry. Yeah. Minus 1 upon x plus c. Have you got the answer now? Yes. Please let me know. Okay, you want to take a screenshot? Just take a screenshot. Okay. Okay, you've got the answer now. Let us go to the next sum. So what we have done here is we have tried to understand what is integration. Then we have understood what are the various differentiation formulae. Once we have understood the differentiation formulae and we are going to revise with the indices formula, I'm using indices as well as differentiation formula in my head. Then I'm able to understand the integration formula, and for each formula we are taking the sums. Okay, and here whatever adjustments are there, in terms of indices I have put it in the color, in a different color, so that you will be able to make out, okay, how or what is the important step while trying to solve a particular sum. For some sums, it will be happening that you will directly get a sum where you can apply the formula directly. But what about the sums where it is not so? So in that case, you should be able to rearrange the terms. Okay, rearrange the term. So if in this case I have to write square root of x as x raised to half. In the other case I have to use a plus b whole square formula. Okay, so all those things you have to consider. Okay, like in this case, all you need to do was you need to know integral of a raised to x log x is equal to a raised to x upon a raised to x dx is equal to a raised to x log x plus c. Okay, so here it is a simple straightforward sum. But what about this case? In this case, x root square root of x is what? It is not only using square root is equal to brackets raised to half, but it is also using the indices a raised to m into a raised to n is equal to a raised to m plus n. Okay. In the next unique sum, that is x plus 1 upon half whole square, we are using a plus b whole square formula. Okay. So not only we are using integration formula, but we are also using the formula for this. Okay. Swati, x cube kahan se hai? Which sum? Okay, here. I'll show you. I'll just show it again. Okay. Yeah, I know that is why I'm taking it very slowly. I don't want any confusion to be there in your mind. Okay, I have integral. Oh, let me change the color. I have integral x plus 1 upon x whole square. Okay, dx. Okay, this is my sum, right? Now this inside this bracket whole square, I'm using the formula a plus b whole square. What is a plus b whole square? A square plus 2ab plus b square. So integral of, okay, forget about integral. Right now, let me first solve the bracket. Therefore, I have x plus 1 upon x whole square is equal to, what is a? A is x. Okay. Then a is equal to x and b is equal to 1 upon x. So this is equal to x. X square plus 2 into x into what is b? B is 1 upon x. Plus b square will be 1 upon x the whole square. Okay, b will be 1 upon x the whole square. Which is equal to, how much is x? So this is x square. How much is this? This x will cancel with this. This x will cancel with this. So what am I left with? I'm left with is 2. And what is this? This is equal to 1 upon x square. Okay. 1 upon x whole square is 1 upon x square. Okay. This is equal to x square plus 2 plus 1 upon x whole square will be x raised to minus 2. Okay. I know because I'm using 1 upon a to be equal to a raised to minus 1 in formula from the indices. So now what happens is, now that means for x plus 1 upon x whole square, I can write this as x square plus 2 plus x raised to minus 2. So that when I have integration of x plus 1 upon x whole square dx, this is equal to integration of x square plus 2 plus x raised to minus 2 dx. This means whenever there is addition subtraction, I can take the integration inside the bracket. So this is equal to integral x square dx plus integral 2 dx plus integral of x raised to minus 2 dx. Okay. Okay. Which formula of the integration I'm going to use? I'm going to use integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Now here what is happening? What is the value of n for this? Now this is x square. So this will become x raised to 3 upon 3. Okay. N becomes n plus 1. So 2 will become 2 plus 1, that is 3 plus 2. This is 2 integral dx. 2 integral dx, I know. Okay, I know. Okay, we've already done that. Integral dx is equal to x plus c. Okay. So integral 2, so 2 I take outside the integral because integral of c fx. Okay. Any function, if it is multiplied by a constant, this is equal to c integral of fx. Okay. So you can take the integral, you can take the constant outside. Like we did in differentiation, same thing. Okay. If I have to differentiate 3x, I used to take 3 outside and then I used to differentiate the x. Similarly here. Okay. So my integral of x square becomes x cube upon 3 and this will become 2x. Okay, because 2 outside integral dx becomes 2x plus, okay, now this is x raised to minus 2. So minus 2 plus 1 becomes x raised to minus 1 upon minus 1 plus c. C is a constant. So this is equal to x cube upon 3 plus 2x. Now, instead of writing plus and denominator, I write it as minus. Now, x raised to minus 1 can be written as 1 upon x plus c. Is that clear now, Swati? How I got the cube? Yes, Kavya also? You've understood now? Yes, Swati, Aryan, Nabeen. Yes, Nabeen, now you understood how the 2 became 2x? Okay. Okay. I'll show it here also. You have integral 2 dx. This is written as 2 integral of 1 dx. Or this is also written as 2 integral dx. Now, integral of dx is equal to 2 into x. Okay. Now, sorry. Is that clear now? Yes, Aisha. Now, have you come to know how 2 became 2x? Nabeen? Yes, Sunil. Very good. Very good. Kushal Jain. Now you understood how x square become x cube? Okay. Yes, Ritu, you understood now properly? Tanmeet clear? Yes, Swati is clear. Liza, Dimple, Ayushi, Aisha, Kushal, yes. Excellent, Kushal. Now you understood? No, Asif, you will not assume 3. Why you need to assume 3? It is x square, so 2 plus 1 becomes 3. Okay, there is nothing of assumption. Okay, everything is there, you have to use it. Okay, Asif, any doubts you still have, just let me know. Now this sum, next sum we are doing is integral of square root of x, x cube plus 2x minus 3 dx. Okay. Now consider square root of x, which I can write it as x raised to half. Okay. This is the first thing. Now let me consider square root of x, x cube plus 2x minus 3. Whenever I have algebraic things inside the integration, I will first simplify that. Okay, so first concentrate on simplifying the equation that is given inside the integration sign. Once I simplify that, it is very easy to apply the formula of integration. Okay. Now, instead of square root of x, what will I write? X raised to half. So this is equal to x raised to half x cube plus 2x minus 3. I will expand the bracket. So this will become x raised to half into x raised to 3 plus 2 into x raised to half into x minus 3 x raised to half. Okay, I have simply like what done what I have expanded. So one I have multiplied this with this, then I have multiplied this with this, and then I have multiplied this with this. Okay, now what else I'm going to use? I'm going to use a raised to m into a raised to n is equal to a raised to m plus n. Okay, so this will become how much? 3 plus half is 3.5. So this is equal to x raised to 7 by 2. 1 half plus 3. Okay, 1 half plus 3 is equal to, what is the LCM here? 1. So upon 2, 1 plus 6. Now this becomes 7 upon 2. Okay, now plus this will become 2 x raised to this is simply x. This means x raised to 1. 1 plus half is x raised to 3 by 2 minus 3 x raised to half. Okay, so this whole thing root x, x cube plus 2x minus 3 has become equal to this much. Okay, I resubstitute. My integration will now become integral of square root of x into x cube plus 2x minus 3 dx will now become integral of x raised to 7 upon 2 dx plus 2 raised to integral x raised to 3 by 2 dx. Okay, I know the constant I can take outside, minus 3 integral of x raised to 1 half dx. Now I will apply this formula, x raised to n dx is equal to x raised to n plus 1 upon n plus 1. Now this is becoming what? X raised to 7 by 2 plus 1. Now let me show it for 1. Now I have 7 by 2 plus 1. So denominator is 1. This is equal to upon 2. 7 plus 2. Okay. Will be equal to 9 upon 2. Okay. I have done it for 1. You can do it for all the others also. So x raised to integration of x raised to 7 by 2 dx will become x raised to 9 by 2 upon 9 by 2 plus 2 into x raised to 3 by 2 will become 3 by 2 plus 1. So this will become x raised to 5 by 2 upon 5 by 2 minus 3 into x raised to half will become x raised to half plus 1 x raised to 3 by 2 upon 3 by 2 plus c. Okay, don't forget the c. So this is becoming what? This is becoming 2 upon 9 x raised to 9 by 2 plus 4 upon 5 x raised to 5 by 2 minus 2 x raised to 3 by 2 because this 2, this 3 and this 3. This 3 and this 3 will get cancelled, and so I have this plus c. Okay, 2 by 9 x raised to 9 by 2, 4, 5 minus 2 x raised to 3 by 2 plus c. Okay. Is that clear now? Yes, Sunil, integration is reverse of differentiation. Yes, Nabin, now clearly understood. Mahima, excellent. Kushal, Aisha, yes, Sunil. Kevin, Mahima, yes. Yes, Ritu, very good. One, see, Ritu has practiced it once, so now it becomes easier for her to say. Santosh Kumar, the PDF has been uploaded, so you can download the PDF and there all these formulae are there. Okay? Yeah. Okay, very good. Now let us do the next sum. Now we will go in for the exponential sum. So e raised to 3x plus e raised to minus 4x. Then let us do that. Yes. So integral of e raised to 3x plus e raised to minus 4x plus dx. Okay. So e raised to x is equal to e raised to ax upon a. So here what will happen is this is equal to integral of e raised to 3x dx plus integral of e raised to minus 4x dx. Okay. For this, how much is a? A is equal to 3. And for this, how much is a? A is equal to minus 4. Okay. So that I have this becomes e raised to 3x upon 3. Now this is minus 4. This becomes minus e raised to minus 4x upon 4 plus c. Okay. So integration of an exponential function will be very easy. Okay. Clear? See, we get so worried exponential functions. How will I solve it? I don't know anything. You only need to know the formula. It's an MCQ, isn't it? They don't want an explanation that show me a graph of an exponential function, etc. They don't need that. So here you can solve it very nicely if you know the concept of indices and you know the formula of differentiation and integration. Okay. Now let us do this. Now there are two ways of doing this. Okay, one is the method in which you do an actual division, or you can do it by just rearranging the terms. Okay, so I will show you both the method. I hope I've taken paper. Yeah, that's possible. So first I'm showing you by division. Okay, actual division. So what I do is I have to consider only this function x square upon x plus 1. So I will write x square normal division. Like if I have say 108 divided by 2, what we used to do in the junior class? Upon 2. So 2 5s are 10. I have to subtract and then I have to bring down this 8. So 8, 2 4s are 8 and then remainder was, this was what? This was the remainder. What was this? This was the quotient. And this is what? This is the divisor. Okay, so now I am dividing x square by x plus 1. Okay, x square upon x 1. When will I get an x square here? X should be multiplied by x. So x into x is giving me x square. X into plus 1 is giving me plus x. Now I subtract, so this becomes minus, this plus becomes minus, this plus becomes minus. So what do I get? This x square plus x square will cancel with this plus x square and I get minus x. Okay, and I get minus x. So that this x square upon x plus 1 becomes equal to x plus quotient plus divisor plus remainder is minus x upon x plus 1. Okay, so this now becomes, because otherwise it's very difficult for me to solve it. Now I will integrate. So this integration of x square upon x plus 1 dx, let me just put it over here, is equal to integral of x dx plus oh no, I haven't finished this division. Just a minute. We haven't finished it over here. Now this is minus x. So minus x and x, how will it happen? It will become minus 1. So this becomes minus x into x will become minus x. Minus 1 into plus 1 will become minus 1. And then when I change the sign, this minus will become plus and this minus will become plus. So this will get cancelled and I'm left with this plus 1. Okay. So my x square will become x minus 1 x minus 1 plus 1 upon x plus 1. Okay. This is my quotient. This is my remainder. And this is my divisor. So x square x plus 1 dx will now become integral of x dx minus integral of 1 dx plus integral of 1 upon x plus 1 dx. Okay. So this will become, what will x dx become? Integral of x, it will become x square upon 2. Now integral 1 dx will be equal to minus x. Okay. Plus integral of 1 upon x plus 1 will become plus log x plus 1 d and plus c. Okay. Log of x plus 1 plus c. X square upon 2 minus x plus log of x plus 1 plus c. Okay, this is one method of doing it where I have done the actual calculation. Okay, I have done the actual division and then I found the quotient, I found the remainder, I found the quotient, I found the remainder and then I wrote them. Okay, this way. So this is one method of doing it. The other is by rearranging it. Okay. Now let me show you that also. So this is x square upon x plus 1. Now here I will write x square upon x plus 1 and instead here I will write minus 1 plus 1. Okay. If I write minus 1 plus 1, I'm not changing anything of the fraction. It will remain the fraction. Minus 1 plus 1 is 0. So it will become x square upon x plus 1. There is no issue. Now this is equal to. Now I will consider this. This is what? This is of the form. Which formula am I using? A square minus b square is equal to a minus b into a plus b. Okay. This I am applying over here. Okay. So here what will happen? This will be equal to x plus 1 into x minus 1 plus 1 upon x plus 1. Okay. So instead of x square, I'm writing x square minus 1 plus 1. So that will become x plus 1 and x minus 1. Okay. So because I'm using a square minus b square, which is equal to a minus b into a plus 1. Now I write this. So I will write this as x plus 1 upon x minus 1 upon x plus 1 plus 1 upon x plus 1. Okay. So instead of x square upon x plus 1, I have written it like this. Now you can easily see that this x plus 1 will get cancelled with this x plus 1. Okay, you can easily see that. So then this will become x square upon x plus 1 now becomes x minus 1 plus 1 upon x plus 1. Okay, it has now become this. So now what will happen is integral of x square upon x plus 1 is equal to integral of x dx minus integral of 1 dx plus integral of 1 upon x plus 1 dx. Now integral of x dx will be equal to x square upon 2 minus integral of 1 dx or dx is equal to minus x, and integral of 1 upon x plus 1 will be equal to plus log of x plus 1 plus c. I think you will be able to appreciate both the answers are same. Here also I have got x square minus x plus log of x plus 1 plus c. Here also I have got the same answer. Okay. Here simply what I have done this x square minus 1 plus 1. Okay. What I have done in the earlier sum, earlier method we are talking about actual division. So I divided x square with x plus 1. So x into x the x square, x plus 1 the plus x. Okay, and then I subtracted. This became minus, and I got minus x. Now this minus x, what happens? I have to multiply by what? I have to multiply by minus 1. Minus 1 into x will give me minus x. Minus 1 into plus 1 will give me minus 1. But all the algebraic terms are finished. So this becomes plus and this becomes plus. So this gets cancelled. So it's plus 1. What is this? This is the quotient. What is this? This is the remainder. And what is this? This is the divisor. Okay. So we have used that and expanded and we got this. Is that clear now? Yes, Tanmit, very good. Yes, Asif, excellent. Yes, Kushal and others. See, there is a printing mistake, okay? For e raised to 3x question, this question. Either they wanted to write here as 2x or they wanted to write here as here itself, or in the answer they have written incorrectly. Okay, so instead of 3, you have to take it 2 then. If you want the same answer as the book, you should take the question as integral of e raised to 2x plus plus e raised to minus 4x dx. Okay, it's a small printing mistake. Instead of 3, they've written 2, nothing else. Aisha, division is not confusing. If you are used to dividing, if you have done mathematics in 9th and 10th, or even 11th and 12th, there we used to do a lot of this. So if not, then you can use this. That's why I have given you both this method. Okay. Here you have to just write plus 1 and minus 1, but then again you should be able to very smartly select, because in the denominator I have x plus 1. I have written minus 1 plus 1. Okay, had there been another number, I would have to use the square. Okay, because I am using the formula a square minus b square. Yes, Kushal? Yes, Tamanna, we are using the quotient rule to solve this also. Okay, you can do that. Oh, yes, I will do that. Okay, Kevin, I will do that. Tanvit understood, Dimple understood. Nabina, if you joined late, otherwise in the first 5 minutes only I have shown how integral of 1 dx is equal to x. Okay, because we are taking n is equal to 0 and then we are doing that. Okay, I'll just show you that screen. Okay, here this fourth sum, I have solved it over here. Here, this one. Okay. How 1 dx? Yeah, I've shown you. Integral dx, integral 1 dx. Okay. You can watch the video again. Okay. And then you. Yes, Kavya, break. Yes. Yes, Kevin, after the break, I will show you one more example of how we can do actual division. We have, I think, sums where we'll be doing that, but still other than that also I'd like to show it to you. Yeah. Yes. Okay. Vinuji, break le le? Welcome back. Okay, so now the next sum that we are going to do is this one, x cube plus 5x square minus 3 upon x plus 2. Okay, Kevin, you wanted this division sum, so I'm taking this division sum. So we will be using the division, simple division method. Okay, so what I have here is x cube plus 5x square minus 3. You are supposed to divide it by x plus 2. Okay. Now for getting x cube, I should multiply x by how much? For getting x cube, I should multiply x by how much? X square. So x square. X square into x is x cube. X square into 2 is plus 2x square. Okay. Now I subtract. This plus becomes minus. This plus becomes minus. Okay. So what do I get? This becomes how much? This becomes 3x square minus 3. 3x square minus 3. Now I have to multiply by how much? To get 3x square, so I have to multiply by 3x. 3x into x will become 3x square, and 3x into 2 will become 6x. Now I can't write this below this minus 3. I will write it here, plus 6x. I will have to write one below the other the same powers. Okay, so 3x square and this 3x square I have written here. Okay, now I again subtract. This becomes minus and this becomes minus. Let me not put this line like this. Okay, and now this will again cancel. 3x square minus 3x. Now what do I get? Minus 3 and minus 6x. Okay, so I get minus 6x minus 3. How will I get minus 6x? When I multiply this by minus 6. Minus 6 into x will become minus 6x. Minus 6 into 2 will become minus 12. Okay. So again, this becomes plus, this becomes plus. So plus 12 minus 3, what will be the remainder? Remainder will be 9. Plus 12 minus 3, remainder will be 9. What is this? This is the quotient. And this is the divisor. And this is the remainder. Okay. So now what has this become? So x cube plus 5x square minus 3 upon x plus 2 has now become equal to, this is my divisor. So x square plus 3x minus 6 plus 9 upon x plus 2. Okay, this has become, this is my quotient plus remainder upon the divisor. Okay, so now I will have this integration of x cube plus 5x square minus 3 upon x plus 2 dx to be equal to integral of x square dx plus integral of 3x dx minus integral of 6 dx plus integral of 9 upon x plus 2 dx. Okay. So what will this be? X square. What is the integration of x square? X cube upon 3. What is the integration of 3x? It will be 3x square upon 2. What is the integration of 6 dx? 6 will come out of the bracket. Out of the integration sign, integral of 1 dx is x. So this becomes minus 6x. And what will this become? 1 upon x plus 2 is how much? It is equal to log. So plus 9 log x plus 2 plus c. Okay, this will be the integration of this. X cube upon 3 plus 3x square upon 2 minus 6x plus 9 log x plus 2 plus c. Okay, I'm just verifying the answers also. So, Kevin, I hope you have understood how we will be using this. Okay, where is the questions? Yes. Hope you have everybody is understood now. Yes, please put in the chat box whether you've understood. And if you're watching on YouTube, you can even press the like button if you're liking this, so that once whenever you want to search for this video again, you only have to check which are the videos you have put the like button, and then you will get them together. Yes, Dimple has also got the answer. Very good. Yes. So here main thing is how to divide. So simple division we have divided. Then we will write the fraction as quotient plus remainder upon the divisor. Now we will be using method of substitution. Okay. See, for example, in this question, if I have integral of x raised to 7 dx, what happens is, it's very easy. I will write it as x raised to 8 upon 8, right? But here inside, can you see this is a function of x? It is not only x, it is a function of x. Whenever you have such questions, it is advisable for you to write this as we will substitute 2x plus 3 as another function, and then we will be doing it. Now for the second question, for this question, again the same thing is here. Here you can see this is raised to 3. What is the power of x in the denominator? Power of x in the denominator is 6. 2 into 3, 6. And what is the power? It is 3. So we can use the division only when the power of x in the numerator is more than the denominator. Okay, because here it may look like x square, but x square raised to 3. So this is a plus b whole cube. A plus b whole cube, you know, is a cube. What is a here? X square. So x square cube, that is x raised to 6. And the numerator, it is 3. So I cannot use the division method here. So I have to search for another method, and that's why we are using the substitution method. Okay. So here also I will be using the substitution method, and here also. Okay. So I'll show you. And you cannot even expand, isn't it? Because this is raised to 7. Had it been a plus b whole square or a plus b whole cube, I could have still done it. Or once you know the binomial expansion, then also you can do it. But for that, you have to wait till statistics, you know. So you can use a plus b raised to n is equal to nc0. Okay, all those things you can do that. You can do that also, but it becomes long. Here, this method becomes easy when I substitute. Okay, so I get the answer quickly. Second last step, yes. Okay, so I have here written for this as this, okay, because I've written, and then here what happens is I am finding the integration of x square. X square becomes x cube upon 3, 3x becomes 3x square upon 2, and so on. Okay, and here what have I written? Okay, this whole thing I have written in terms of quotient plus remainder upon divisor. Okay, so this is my quotient. See, you can see the quotient plus remainder. Remainder is 9 and divisor is x plus 2. Okay. Yes. Yes. Nabeen has also understood. Mahima, Kushal. Dimple, Kevin. Okay, now you've understood. Ashutosh, what do you want to tell? This message is I can see. Okay. Baba Sahib has also understood. So now let us go to the next one. So here I'm using the method of substitution. So put 2x plus 3 equal to t. Okay. Once I put anything equal, once I use substitution, always remember I have to also substitute for dx. Okay. So very important is that I find the value of dx also. Now differentiating on both sides. Differentiating on both sides, I get, what will happen? 2x will become what? Derivative of 2x is 2. And differentiation of a constant is 0. So this is 2 dx plus 0 is equal to dt. Okay. Differentiating on both sides, we get 2 dx. Why we are writing dx and why we are writing dt here? Because on the left, it is differentiation with respect to x, and on the right, it is for the t. So that is partial differentiation we are using. So 2 dx plus 0 is equal to d. So dx is how much? Dx is equal to dt upon 2. So for this, for 2x plus 3, I'm going to substitute what? T. For dx, what am I going to substitute? Dt. So my equation, that is integral of 2x plus 3 upon raised to 7 dx, raised to 7 dx will now become, instead of 2x plus 3, I'm writing t. So this is integral of t raised to 7. Instead of dx, what I'm writing? dt by 2. So into dt by 2. Constant, I can take outside the integration sign. This is equal to 1/2 integral t raised to 7 dt. Now I will use x raised to n is x raised to n plus 1 upon n plus 1. This will now become 1/2 t raised to 8 upon 8 plus c. Okay. Now 2 into 8 is 16. So this is equal to 1 upon 16 t raised to 8 plus c. Now 1 upon 16. What is t? I will resubstitute. Resubstitute value. So t, instead of t, what will I write? 2x plus 3. So this is 2x plus 3 raised to 8 plus c. Two x plus 3 raised to 8 upon 16 plus c. Sunil, it is a general formula. We have done it in the, I think, 4th or 5th standard, isn't it? We used to do that. Let me show you. Suppose I have 59 divided by 3. Okay. So what I used to do? 3 ones are 3. Then I used to subtract. It becomes 29. 3 nines are 27. Remainder is 2. So how do I write 59 divided by 3? Into mixed fraction, it is used to be 19, 2 upon 3. Right? What is this? This is simply written as 19 plus remainder upon quotient. Okay. No, this is quotient. This is quotient, remainder upon divisor. Okay. Which, when written in mixed form, used to get you this. Is that clear? Same thing, but only we are using x. We have done, Aditya. Okay. Okay, where did I get the 16 from? 1 upon 2, you have understood? Okay. This is the 2 we are talking about. Dx is 2 dx is equal to dt. So it is dt upon 2. So this 1 upon 2 is there. Now when I want to integrate x raised to 7, so that is t raised to 7. What is t raised to 7 integration? X raised to n plus 1 upon n plus 1. So t raised to 7 becomes t raised to 8 upon 8. Okay. 7 becomes 8 in the numerator and it comes in the denominator also. Now this 2 into 8 becomes 16 here. Okay. Next sum we are doing is this x cube upon x square plus 1 whole cube. Okay, here as I told you that the power of x in the numerator is 3, whereas the power of x in the denominator is 6. So you can use the division only when the power of x is more in the numerator and less in the denominator. Okay, other than if that is not the case, then we will have to use this or partial fraction method. Okay, either the substitution method or the partial fraction method. Now what happens here is this, we are using the substitution method. So put x square plus 1 is equal to t. Differentiating on both sides, I get 2x dx is equal to dt. Because differentiation of 1 is 0, so it remains 2x dx is dt. So I here have got this x dx is equal to dt upon 2. Now why I did not take the x downstairs? Because if I take the x in the denominator here, it will not serve my purpose. Okay, so I will keep it like this. And why? Because I want everything to be in terms of t now. Okay. So now my x cube, this is the most important step. X cube should be written as x square into x. X cube has to be written as x square into x. So my integration becomes x square into x dx upon x square plus 1 whole cube. Now instead of x dx, can you see over here, instead of x dx, what am I going to write? I am going to write this dt upon 2. So instead of x dx, I'm going to write dt upon 2. Now what will happen? Instead of x square, what should I write? Now here what is given to me is x square plus 1 is equal to t. Instead of x square can be written as t minus 1. Okay, I just take this 1 over this, so it becomes t minus 1. So my integral will now become, instead of x square, what am I going to write? T minus 1. T minus 1. Instead of x dx, what do I write? Dt upon 2. To dt upon 2. And in the denominator, x square plus 1 whole cube, what am I going to write? X square plus 1 is t. So this becomes t cube. Okay. So t minus 1 upon t cube into dt upon 2. I will take 1 upon 2 outside the bracket. So this becomes 1 upon 2 integral of t upon t minus 1 upon t cube dt. Okay. Now I will expand this. So this is equal to how much? 1/2 integral t upon t cube dt minus 1/2 1 upon t cube, okay, dt. 1 upon t cube dt. This is not looking good. Okay. Now you can see it properly. Dt. Now t upon t cube, I can simplify. This becomes t cancels and this 3 becomes 2. Okay, so now what happens here is I will use t raised to n, x raised to n is equal to this formula. So now this is equal to 1/2. And now I have 1 upon t square, which is written as integral of t raised to minus 2 dt, because it is t square in the denominator. I am also using which formula, that is 1 up, which indice 1 upon a is written as a raised to minus 1. So t 1 upon 2, 1 upon t raised to 2 becomes t raised to minus 2. Okay. Minus 1 upon t, t integral of t raised to minus 3 dt. Now this becomes equal to 1/2. T raised to minus 2 becomes t raised to minus 2 plus 1 upon minus 2 plus 1 minus 1/2 t raised to minus 3 plus 1 upon minus 3 plus 1 plus c, which is equal to how much? 1/2 t raised to minus 2 becomes how much? This is equal to 1/2 t raised to minus 1 and minus 2 plus 1 becomes minus 1. Minus 1/2 t raised to minus 2. Okay, t raised to minus 2 and this becomes minus 2. Minus 3 plus 1 becomes minus 2 plus c. Now this can be written as how much? This is minus sign. So this becomes minus 1 upon 2t. T raised to minus 1 is simply 1 upon t. And here it becomes minus 1 upon 4. Minus minus plus. Plus 1 upon 4 t raised to minus 2 is written as 1 upon t square plus c. Okay. Now resubstitute. Resubstitute x square plus 1 is equal to t. Okay. So I get it is equal to minus 1 upon 2 x square plus 1 plus 1 upon 4 x square plus 1 whole square plus c. Okay. Now if I don't want to write it minus sign first, this can also be written as 1 upon 4 x square plus 1 whole square minus 1 upon 2 x square plus 1 plus c. Is that clear? No, Lisa, same answer you should get. Priyanka, you will have to, solve it again and again. See, what you do is, you see the sum, same sum you try to solve on your own. Now you've seen the video. After the class is over, you try to solve it again. If you're not, go back to YouTube, see what the solution was. Again, shut down the YouTube, again try to do it on your own. Okay, only then it will happen. Yes, yes, Nikita, I'm explaining again. Okay, okay. What about the others? Have you understood? Yes, Dimple, it's a little tricky, no doubt about it. That's why I'm taking it as slowly as possible. Yes. Okay. See, what do I have? I have x cube upon x square plus 1 dx. Okay. This is what I've asked to find out. Whole cube, I think. No? Now, instead of x cube, I'm going to write it as x square into x. Why x square? Because here in the denominator I have x square, so I'm using x square over here. Okay, so that I know that I'll be able to express this in terms of t. Okay, this is just a step to understand. Now, important step is, because what you want to substitute is also very important. Let x cube plus x square let x square plus 1 be equal to t. Then differentiating on both sides, I get 2x dx. Derivative of x square is 2x dx. What is derivative of 1? It is 0 is equal to dt. Now x dx is equal to dt upon 2. Okay. Here, once I've written this like this, this is equal to integral x square into x dx upon x square plus 1 whole cube. Now, instead of x dx, I'm going to substitute what? I'm going to substitute dt upon 2. Instead of x square plus 1, what am I going to substitute? I'm going to substitute t. These are the two substitutions you should understand. So now this becomes, instead of x square, what will I write? Using this implies what? X square is equal to t minus 1. X square plus 1 is equal to t implies x square is equal to t minus 1. So instead of x square, what do? I write it as t minus 1. Instead of x dx, what do I write? I write down dt upon 2. And instead of x square plus 1, what do I write down? X square plus 1 is t. So this is t cube. This becomes, now this is half, so I write it as half integral t minus 1 upon t cube dt. This is t minus 1 upon t cube dt. So this is equal to how much? I just expand the bracket, t upon t cube minus 1 upon t cube. Okay. So minus is equal to 1 half t upon t cube integral dt minus 1 half integral 1 upon t cube dt. So this is how much? 1 upon t square. 1 upon t square is minus t raised to minus 2. So this is 1 half into t raised to minus 1 upon minus 1 minus 1 half t raised to minus 2 upon minus 2 plus c. How I'm using the simple x raised to n. The integration is x raised to n plus 1 upon n. Because this is a minus sign. Okay, because this is minus 2, it becomes minus 2 plus 1 becomes minus 1. Minus 3 plus 1 becomes minus 2. So this. Okay, and I resubstitute. So once I resubstitute, so what have I got? This minus 1 into 2 becomes minus half t raised to minus 1 minus minus plus 1 upon 4. This 2 into 2 becomes 4. T raised to minus 2 plus c. I resubstitute t to be equal to x square plus 1. So this becomes minus 1 half x square plus 1 raised to minus 1 plus 1 by 4 x square plus 1 raised to square plus c. Okay. Now what happens here is and this minus 2. This is equal to, because this is a plus number, I'm writing it first. So 1 upon 4, 1 upon x square plus 1 whole square minus 1 by 2 x square plus 1 plus C. Okay, correct? Yes. Okay, I have explained it to you 3 times now. Yes. Aishi? Yes, Kevin, the more you practice, you will come to know. Okay. Substitution method will be a easier method. So we could start off with that. Yes. And then we could go further. First see whether the division method is easily possible. So that becomes, then you could do that. Once that is done, if it is possible, continue with that. If not, then you can go for any of this method. If it is simple division, the numerator, the power is more than the denominator. So you go in for direct division. When it is not so, then you have to use either partial method or substitution method, or you will have to do this type of rearrangement. Now another method, that is method of partial fraction, is used when the power in the numerator is less than the denominator. Okay, so in this case, what is the power of x here? Power of x is equal to 1. Okay, this is raised to 1, so this is 1. Now here it may seem like 1, but there is a multiplication. So x into x is how much? X square. Okay, so power of x in denominator is 2. So in that case, use the partial fraction method. Now here, what we are going to do is, we have to just arrange this in the form of whatever there is in the denominator. So I have to arrange this in the form, this should be equal to integral of a upon x minus 2. That is the first fraction here, dx, minus or plus integral of b upon, what is the second? X minus 3 dx. Okay, I want to, because this is complicated, because in the numerator my power is less than the denominator. Had it been more, I would have used the division method, but that is not possible. So I have to use this. Now what this means is, I want to express it in this form. So it means that 3x plus 2 upon x minus 3, x minus 2 into x minus 3 is equal to a upon x minus 2 plus b upon x minus 3. Numerator, let it be as it is on the left hand side. On the right hand side, this is the case. Okay. So now I will cross multiply, because what I want to equate the denominator. So try to equate denominators. Okay. So this will become what? X minus 2, and this becomes x minus 3. Okay. I found the LCM, which is the same as this. So this will become a into x minus 3. Cross multiplication. Okay. Plus b into x minus 2. Isn't it? So now denominators are same. Denominators are same. We equate numerator. Okay. So this becomes 3x plus 2 is equal to a into x minus 3 plus b into x minus 2. Now this is, I expand, a into x will be ax, a into minus 3 where will be minus 3a, b into x will be plus bx, and b into minus 2 will be minus 2b. Now important step, rearrange so that all x terms are together. Okay. So what happens now is I'm rearranging. So I have 3x plus 2 is equal to ax plus bx. This is a plus b into x, and minus 3a minus 2b. I will write together. Minus 3a minus 2b. Next important step here is equate terms in x and other terms. Okay. So 3 will be equal to a plus b. Okay. Because 3x is equal to a plus bx. Okay. So 3 is equal to a plus b, and 2. This remaining is plus 2 is equal to this total. 2 is equal to minus 3a minus 2b. Now I have got two simultaneous equations in a and b. So I have a plus b is equal to 3 and minus 3a minus 2b to be equal to 2. Solve the simultaneous equation. So multiplying first equation by 3, minus 3. So minus 3a minus 3b is equal to minus 9, and this becomes minus 3a minus 2b is equal to 2. Subtracting, you have this. You have minus b is equal to minus 11, or b is equal to 11. So I have been able to find the value of b. Now I have the value of b, then I can put a plus b is equal to 3. A plus 11 is equal to 3. So a is equal to 3 minus 11, which is equal to minus 8. So I have the value of a equal to minus 8. I have got b, I have got a, so that I can write 3x plus 2 upon x minus 2 and x minus 3. X minus 2 into x minus 3 as equal to minus 8 upon x minus 2 plus 11 upon x minus 3. Okay. See here I had written 3x plus 2 upon this is equal to a upon x minus 2 plus b upon x minus 3. I found the values of a and b, so I am substituting. So integral of 3x plus 2 upon x minus 2 into x minus 3 dx is equal to, now see this becomes so simple, minus 8 integral of 1 upon x minus 2 dx. Can you appreciate? You know, this is so simple now. Plus 11 integral of 1 upon x minus 3 dx. Okay. Which formula are we using? Integral of 1 upon x dx is equal to log x. Okay. We are using that. Let me write it in a different color so that you know it's a formula and not part of the question. So which formula am I using? Integral of 1 upon x dx is equal to log x plus c. Okay, this we are using over here. And so this becomes, this is equal to minus 8 log of x minus 2 plus 11 log of x minus 3 plus c. Okay. This is what you have the answer. Yes, Ritu. Now we are using log formula. Okay. So this is the answer. Yes, Nabeen, high concentration is required here. So whenever such type of sums are given where the power of x in the numerator is less than the denominator, we prefer to use the partial fraction method. So in that, I'm going to write this in terms of two fractions, okay? Depending on how many factors are there in the denominator. In this case, there are two factors, so I'm using the two factors and the power of x is raised to 1. So here I'm able to do that. So I'm writing 3x plus 2 upon x minus 2 into x minus 3. Here, this is the most important step. So let me. Okay, this is the most important step that you will be doing. So 3x plus 2 upon x minus 2 is equal to a upon x minus 2 plus b upon x minus 3. These are nothing but these terms, okay, x minus 2, x minus 3. So we have done that. Then we try to equate it. How do I do that? By taking the LCM. So here this step is taking LCM. So in the LCM, what I've done, I've cross multiplied a into x minus 3 plus b into x minus 2 and I've got this. Then we will, denominators are same, so we equate the numerator. Okay, so this is the next important step where you are using this. Okay, so because the denominators are same, we are equating the numerators. So 3x plus 2 is equal to a into x minus 3 plus b into x minus 2. Okay, now we have got ax minus 3abx. So now the most important thing is here, rearrange so that we get all the x terms together. Okay, so I will take all the x terms. So what are the x terms here? Ax and bx. So I take them together, so it becomes a plus b into x. And then I take the remaining minus 3a minus 2a. So this one. And then we get two simultaneous equations and then we solve those and we get the values of a and b. Once we get the values of a and b, we will just write it in the equation. Okay. So this becomes what? This is simply the formula. This becomes so simple that now we have to just simply substitute the formula. That is for here in this case, it is integral of 1 upon x dx is equal to log x, and then we get the answer. Okay. So there are many other also given in the book, so they are very complicated. You will not get such big sums for MCQs. Up to this sum, it is okay. So those are sums that are there for your better understanding. Okay. Yes, Kavya, you could do that. Yes, thank you, Ritu. You like my teaching? Yes, Aditya. That's what I'm saying. For more factors, what should you do? That it will become a plus b plus c, So, but that will not come for you because this is all MCQ questions. So there is a time limitation, right? So don't get confused. If you are studying for your 12th standard, that is different. You do their sums over there. But in case of foundation, your concept have to be very clear. How big the sums will come, how I will handle it. Okay. So don't confuse the two. Okay. Aditya, understood? Now there are other formulae also. Okay. Scroll up. Kavya, where do you want me to stop? This one? Okay. First take this screenshot. Okay. So once you have done that, this is the one in green is the important step where you are putting A and B. Okay. Once you have introduced the A and B, it becomes simple. Okay. Then you have to rearrange. Okay. And then the second thing is important here. Okay. Rearrange so that all the X terms are together and this way. Okay. Done, Kavya? Yes, your concepts are clear, Kushal? Yeah. Ritu, I'm your favorite teacher. Thank you. Kushal also? Yes. Nabin, second last step? Okay. See, once you have done this, okay, once you have found out the values of A and B, I'll just write it over here. See, what we had done earlier, we have written 3x plus 2 upon x minus 2 into x minus 3 dx to be equal to integral of a upon x minus 2 dx plus integral of b upon x minus 3 dx. Okay. This is how simple we want to write. Okay. Now, for this, we need to find A and B, and we have found A and B. So, this is my A and B. Okay. What is the value of A and what is the value of B? Okay. Any other doubt you have? Okay. Yes. Let us go further. Yeah. These are the important formula we are talking about. Then there are certain formula that have been already there, you just need to know those formula. So dx, that is 1 upon x square minus a square. If I want to find out the integration of 1 upon x square minus a square, which is equal to 1 upon 2s a log of, see, this is a minus sign here. Okay, this is a minus sign. This is also a minus sign in the number. So this is only what you have to remember. 1 upon twice a log of x minus a upon x plus a plus c. And this log applies to the both the terms. Okay. And integral of dx upon a square minus x square. This is x square minus a square. This is a square minus x square. It is 1 upon twice a. So this is minus here and this is minus here. For example, if I want to find out, okay, let me take it here. Okay, suppose my sum is find the integral of 1 upon x square minus 25 dx. Okay. Then first is that you must realize this is of the form of x square minus a square. Here it looks like x square minus 25. ऐसा तो नहीं दिख रहा ना a square. So what I should do is I will write this as is equal to 1 upon x square minus 5 square dx, right? So what is my a? A is equal to 5. So what I will do is this integral is equal to 1 upon twice a 1 upon 2 into 5 log of, okay, x minus a is 5 upon x plus a, that is 5 plus c. plus c. So this is equal to 1 upon 10 log of x minus 5 upon x plus 5 plus c. Okay. Then similarly, I may have integral of 1 upon 25 minus x square dx. Then similarly, I will write this as 1 upon twice a log of 5 plus x upon 5 minus x. Okay. Understood? Then we have the formula for square root. Integral of 1 upon square root of x square plus a square. So you may have find integral dx of under root of x square plus 9. Okay, so in that case you will be using this, which is equal to log of x plus square root of x square plus a square, or you may have it as integral dx x square minus a square is log of x plus under root of x square minus a square plus c. Okay, then you have this you may have square root of x square plus a square. This formula is x by 2 under root of x square plus a square upon 2 log of x plus under root of x square plus a square. Okay. So you can see over here, this portion is similar. Here it is 1 upon under root of x square minus a square. Here what is happening? It is 1 upon, this is x square plus minus a square, but in the numerator. Okay. So this part is there, but this is the additional part that has come into play. Okay. X upon 2 under root of x square minus a square upon 2 log of this. Okay. So these are the formulae that you need to know. Yes, very good. Okay. So you have to just see, once you know this formula in the options, it's very good that you get MCQ. So in the MCQ, we will be seeing those sums also next time. So there you can see, all you need to know is where I have to put the negative sign, where I have to put the positive sign. So here, can you see, this is plus, this is also plus, this is also plus, this is also plus, this is also plus, no problem. This is negative x square minus a square, then this is also negative, this x square minus a square, this whole term is same as this. Then you have negative here and positive here, again negative here. Okay. So I'll just revise those formula. I may have integral of 1 upon x square minus a square, which is 1 upon twice a log of x minus a upon x plus a. Then I may have integral of a square minus x square, then this is the formula. Then I have integral of 1 upon x square plus a square, I have this formula. 1 upon x square minus a square, I have the above formula. Okay, this one. Then I may have integral of 1 upon under root of x square plus a square. This was under root of. Then you have upon x square plus a square and x square minus a square. So what are the different types you may have? Integral of 1 upon x square minus a square dx. You may have integral of dx upon a square minus x square. Then you have integral of 1 upon square root of x square minus a square dx. Then you may have 1 upon, then you may have square integral of x square minus a square. Okay. So all these different types of sum have a different formula which you have to use. Okay. You may have this minus or plus, okay, minus or plus and minus or plus, okay. So depending on the sign, you will have different formula. Tomorrow we will be doing integration by parts. When we have multiplication of two functions, then what will happen is you cannot find the integration directly. Then we have to use this formula integral. This is my first. This is my first function. This is my second function. Okay. So what does the formula says? This is equal to first function into integral of second minus integral of derivative of first function into integral of second function plus c. So here integral of second function is again there is the integration of that function. Okay, and the rule that we are going to use is isolate. But for you, inverse of the trigonometric functions are not there. So what is the order in which? What should I use u and what should I use v? That is done by the late function. Okay, not I. I is because inverse of the trigonometric function. So here we are going to do the logarithmic. Then A is for algebraic. Then trigonometric, again which you won't be having, and then exponential. Okay, so you should always choose your first function to be logarithmic, second function to be in this order: logarithmic, algebraic, trigonometric, and exponential. So whatever combination you have, you follow this this is way in which you can select which of the functions you have to take as u and which of the functions you have to take as v. Yes, Kushal, time. No, Ritu, once you start writing those formula, you will find it. Yes, Ayushi, everything has been uploaded. So please download from the BCC. There I have uploaded this PPT, so you can take it down. And there all the formulas are there in one PPT for integration. The other one was for differentiation also. Rather, whatever subjects, whatever topics I will be teaching, all those PPTs are available for you for your reference. Okay. So that's all for today. Let us continue again tomorrow in a fresh mind, so that integration by parts by fresh minds we can do that. Any other thing that is remaining, I will just go through the sums again, so that we could take up some sums where you will find it easy for you to understand. We'll be revising those sums. Okay. Thank you all for your patient hearing. Have a great evening ahead. Have a great day.